When you have a lot of data in your Django applications, you often want to aggregate that data in order to get insights into values and summary statistics across your broad data set. And this is commonly used when you have dashboards and reporting applications, and when you're creating business intelligence software. You want to get insights into all of the data that's stored in the database, not necessarily on a row level, but as a whole. In this video, we'll look at ways to aggregate and annotate data using the Django ORM. We'll see how we can use aggregation to combine multiple values from multiple rows into a single output value. For example, summing up a column in the database to get a final value that's the sum of all of those values. Another example, taking the maximum value from a column or the minimum value. These are all aggregations that we can apply over a query set of records in our Django applications. We're going to dive into that in this video, and we're also going to see how to use annotation in a Django application. And when we annotate a model in Django, we're adding a summary record or some sort of aggregated record for every single model in the query set. So rather than a single output number, we are annotating every Django model in the query set with a particular value that's not defined by default on that model. We'll dive into that as well. And we're also going to look at two key functions in the Django ORM, the values and values list functions. These allow us to only pull certain values from the database, and rather than storing them in full Django models, we can use Python dictionaries and lists instead, which can be better in terms of performance, but it can also help us with annotation and aggregation. So let's get started and we'll see how we can achieve these things in Django. Now we're going to start by looking at two functions in the Django ORM, and these functions are defined on query sets in Django. And if you look at the right hand sidebar, it's these two functions here, the values function and the values list function. So let's click the values function and we're going to read the documentation here. This returns a query set that returns dictionaries rather than model instances when it's used as an iterable. And each one of those dictionaries represents an object in the database, and the keys correspond to the attribute names of the model objects. So it's a bit different. Rather than a model, it's returning a query set of dictionaries, and we can use this to only fetch a subset of columns from a table rather than all of the columns. Now by default, when you use Django functions, you are going to get all of the columns back in the models for the query set. We saw in a previous video how you can use the .only and .defer functions to change this behavior, but there is a difference here. The only and defer functions, they return Django models with some of the fields missing. The values and values list functions are going to return dictionaries and Python lists respectively. And Django also cautions against the use of only and defer unless you really know what you're doing with those functions. The values and values list functions are a bit safer to use, so we're going to dive in and see how to work with these in this video. Now I'm going to open VS Code, and we have our orm script.py file here, and here's a query that would get all of the restaurants from the database from that restaurant table. Now if we go to the models.py file and we look at the restaurant model here, you can see all of these different fields that are defined on that restaurant model. And let's say that we don't need to get back all of these fields when we issue this query. We only want to get the name of the restaurant, which is a car field, and it's stored in the database for the restaurant's name. We can go back to the script here and we can change the .all function. And instead what we're going to do is we're going to use the .values function. And what we pass as arguments to the .values function are the name of the fields that we want to get back from this particular model. And you can also fetch fields from related models, as we'll see later on. Let's say here that we only want to get back the name field from that table. And once we get that, we're going to get the first record in the table as well. So we're going to extract only one single row from this table. And then we're going to print these to the terminal. Now I've called this restaurants, but it's actually going to be a restaurant model instance. What we're going to do at the bottom is run python manage.py, and we'll use the run script command and run this ORM script. Now you can see at the bottom we get back this dictionary here. It's not a Django model. In this case, because we've used the .values function, it's returning a dictionary. And the keys in the dictionary, in this case the name key, match the fields that we pass in from the model to this values function. And let's say that as well as the name field, we also wanted to get the date that the restaurant opened. If we add that as another argument and rerun this script, we now get back a dictionary that contains two keys and two values. The second key here is the date opened key, which maps to a datetime.date object in Python. So one of the key points in this video is that the values function here is not returning a Django model, it's returning a dictionary, and it's only bringing back the keys that you specify as arguments to the function. And this can be beneficial if you're fetching a lot of data from the database and you don't need to get all of the columns, and you also don't need to construct Python model classes using this method, it's simply going to return the data and construct a dictionary instead. That can be much faster. So that's one benefit of using values. And there's also another function called values list as well. Instead of a dictionary, that's going to return a list of values for each object. Now I'm going to change the name of this variable to restaurant. And we're now going to demonstrate that this is just a dictionary in Python. We can use the normal dictionary notation to get a particular value. And if we rerun the script, we see here we get the name of the restaurant, and that's because we're asking for that particular key from the dictionary that's returned from the .values function for the first row in the database. So to sum up, these dictionaries for the values function, they represent rows in the database table, but only with the columns that you're interested in. And if we remove the .first function here and just look at the query set in general, you can see that what we get back is a Django query set containing dictionary objects. So it's a dictionary, and each one of those dictionaries is for one row in the table, and it contains those two keys for the name of the restaurant and the date it was opened. Now before we move on, what I'm going to do is print the connection.queries, and we're going to see what the query is that's being executed here in order to get back these dictionaries. So let's rerun the script below, and what you can see is this select query here. I'm going to make this a little bit bigger so we can see that. We've got a select statement, but you can see that we're only looking at the date opened and the name columns from that table. We're not getting back all of the columns, so that's one effect of using the .values function. As you can see, it returns dictionaries containing those keys, but the SQL query and the data returned are going to return less data than you would normally use with a Django ORM function. And there's also much less overhead in constructing these dictionaries than there is in constructing the Django model classes, so this can be performant as well. Let's now move on to something a little bit more complicated. It turns out that the .values function can take additional keyword arguments, and these can be used to transform fields and perform aggregations on some of the fields that we're fetching from this particular function. So for example, let's say that we not only wanted to get the restaurant names, but we wanted to get them in uppercase. What we need to do in order to do this is use a Django database function that's defined, and this will then run a function in the underlying database to pull out those values after that function has transformed the values. So what we're going to do at the top is bring in an import from django.db.models.functions. We're importing a function called upper. So what we're going to do here is remove the date open field. We don't need that here. And then instead of just referencing the name here, what we're going to do is give it a keyword argument. I'm going to call that name upper. And we're going to set that equal to calling this upper function that we've imported and passing the name field into that. And let's also only get the first 3 records back from that table. So now I'm going to remove the connection.queries statement, and we're going to rerun the function, or rather rerun the script, and you can see at the bottom we now get this query set where the key is called name upper, and that matches the keyword argument that we passed into the values function. But the value itself is the name of the restaurant, but it has been converted to uppercase, and that's being done at the database level by this function. So these functions that are defined in Django's db.models.functions module, they operate at the database level. And in order to see that, we can bring back the connection.queries and rerun the script. And then when we look at the SQL statement, you can see that not only is it selecting the name column, but it's passing the database upper function there, and that's where this conversion is occurring. Let's now move on. Earlier on I mentioned that we can get foreign key fields using the values function as well. So what we're going to do now is we're going to try and get all of the ratings from the database, but we're also going to get the name of the restaurant that's attached to that rating. So restaurant is a foreign key on the rating model. We want to follow that foreign key and get the name field out when we use this values function. So I'm going to remove these 2 lines at the top here, and I'm going to set up a reference to the restaurant.typechoices.Italian value. We're going to pull out Italian restaurants only in this query. So let's do that just now. We're going to use rating.objects.filter, and we're going to filter this by the restaurant's restaurant type. And we can follow that foreign key to the restaurant model from the rating and then access the restaurant type field. And we're going to set that equal to Italian. So what we're doing here is filtering to only the ratings that are applied to Italian restaurants. But what we want to do then is use the .values function here. And let's pull out 2 particular values. Firstly, the raw rating itself, which is the numerical value between 1 and 5. But we also want to get the restaurant's name that has this particular rating. What we can do to get that is use the restaurant field, which if we go to models.py and scroll down to this rating model, this is the foreign key field. It's called restaurant. So we're accessing that in the values function. And again, just like in the filter function, we can use these 2 double underscores here to follow the reference to the restaurant model, and in this case we want to get the name of the restaurant, so we access the name field here, and that's going to give us back the name of the restaurant. So let's store this query in a variable called ratings, and we're going to then print those ratings to the terminal, and I'm going to remove connection.queries and rerun our script here at the bottom. If we look at the results of this script, you can see that it's a query set containing these dictionaries for each row in the database. And if we look at the dictionary keys, we have the rating, for example 2 out of 5, and we also have the restaurant name. And the key for that is just the key that we provide to the values function, and we get back the names of the restaurant. So rather than the foreign key instance, we're getting back a particular field on that foreign key in the values function, and that is the name field. So the key point here is that the double underscore in Django, it can be used in, for example, the filter function, but it can also be used in the string values of fields that we pass to the .values function to follow the foreign key reference. So this is the values function, but we saw in the Django documentation, if we go back here, that there were two functions. The second one is called values list, so let's look at that. This is similar to values, except that instead of returning dictionaries, it returns tuples when iterated over. And each tuple contains the value from the field or expression that's passed into values list, just like the values function. So let's go back to VS Code. I'm going to clear out this code that we had here, and what we're going to do is we're going to go back to the restaurant model, and I'm going to fetch all restaurants here, but what we're going to do is use the restaurant.objects.values_list function. And again, we pass one or more fields to the values list function. I'm just going to pass the name field, and then we're going to print the result that we get back to the terminal here below. So let's clear the terminal and execute this script. And you can see that what we're getting back is a little bit different now. We have a query set as before, but we are not getting dictionaries anymore. We're getting tuples containing, in this case, just the name of the restaurants. So there is a tuple for every row in the table that's returned from this query, and each element in the tuple represents the elements that are passed in. So again, if we pass in date opened as an additional field here and we re-execute the script, you can see that the tuples now contain not only the name of the restaurant, but they also contain this datetime.date object that represents the date opened field in the database. Now, whether to use values or values list, it depends a bit on the context. For me, I prefer dictionaries because it's much more explicit what these values actually are, because they have that key in the dictionary, for example the name key, and you can much more easily tell what the values are representing using that method. But the values list function is handy as well in some circumstances. So let's see another useful example of values list. We're going to show the flat equals true keyword argument, and you can use this when you're only fetching a single field from the values list function. So again, if we re-execute this and we see what happens without that keyword argument, you can see that each element in the returned query set is a tuple with a single value. Now you might want to get a better representation of this. You might not want to have a tuple with a single value for every element in that query set. You might just want to return all of the values in a Python list with no tuples in that query set. So what we can do is we can pass the flat equals true keyword argument to the values list function, and if we rerun this script, you can see that the resulting query set now does not have any tuples. It just contains the strings that represent the restaurant's name. So we've flattened that query set and removed the tuples, and we're just getting back the values of that field. And that will work for any field in the table. For example, if we use the latitude field, which is a floating point number field, we get back a query set where each value in the query set is just the number. There's no tuples here with a single element. So I like this argument a lot, and I use it a lot in Django applications. If you're constructing a list on the back end from database values, this can be a very handy function to use. So that covers the values and values list functions in Django. What we're now going to do is move on to aggregation and annotation. And later we're going to see how to use the values function with annotations in order to help you group data by a particular column. So let's start with aggregation. What aggregation does is it breaks down multiple values into a single value. And it does this by grouping or clustering records on a particular field or set of fields in your Django model. So we're going to see how to use some common aggregation functions now. And let's start with the simplest aggregation. We're going to count the number of records or rows in a particular database table. So I'm going to remove this code here, and I'm going to paste a query that we've already seen in this series, restaurant.objects.count. If we print that to the terminal, you can see what we get back as a result at the bottom is the number of rows in the restaurant table. In this case, it's 14. And we can also perform this counting aggregation on a filtered query set. For example, if we wanted to get only restaurants whose name starts with the letter C, we can use that filter and then use the .count method after that. If we rerun this script, now we get back only 2 restaurants in the table. Now Django has an additional method for aggregation, and that is the .aggregate method. And this method allows more complex aggregations to be performed in your Django model classes. Now the Django models module has some objects for performing aggregations. We're going to see one of those now for the counting aggregation. So at the top, from django.db.models, I'm going to import the count function, and we're going to see a different way of performing this query to get the number of records in the table. So rather than using the .count method, we're going to use the .aggregate method, and what we're going to pass into that is an aggregation that we want to perform. So what we want to pass in here is we want to count the number of IDs in this table, and we're going to print that out to the terminal. So let's rerun this script, and you can see that we have a dictionary that's being returned from the aggregate method, and it has a key called ID count, and the value there is 14, which matches the value that we originally got from the .count function. And if we uncomment connection.queries and save the file and rerun the script, we're going to see that what is executed on the database is the count aggregation function, and that's executed in the underlying database to give us back this value of 14. And note as well that we have an alias to the result here. It's called ID_count, and that matches what we see in the dictionary here. But if we want to give the returned value a different alias, we can pass this as a keyword argument. So for example, to count the number of rows, I might give this a keyword argument of total, and when we run the script again, you can see the dictionary now has a key of total that maps to 14, and you can see the alias in the underlying SQL query has also been changed to total. Now one thing to note is that the aggregate function is a terminal function for Django QuerySets. It returns a dictionary, so we cannot chain additional functions onto that. So it returns a dictionary of key value pairs representing the aggregations that you're performing, but you can't then perform a filter function after that, and that's because this is a terminal clause for a query set. So let's now look at a more interesting aggregation. We're going to look at the average aggregation. Let's say that we wanted to aggregate all of the ratings in the database, and we wanted to calculate the average rating that's stored in this database. If we go back to ormscript.py, I'm going to import another aggregation function from the models module, and that's the average aggregation function. Now at the bottom here, I'm going to comment connection.queries out, and we're going to print a different aggregation here. That's rating.objects.aggregate, and we're going to give the aggregation a name of average, and we're going to use that average function that we've imported and pass to it the rating field. And the rating field is just a field on the rating model. That's the integer field that stores the actual numerical rating itself. So we're going to use that, and we're going to aggregate it and calculate the average rating in this table and print that to the terminal. So let's clear the terminal below here and we'll execute the script, and you can see the average rating in the database is 3. So that's the average rating across all of the rating objects in the database. Again, we can apply a .filter function though, and in this case I'm going to filter to only restaurants whose name starts with the letter C. That will filter down the query set to only 2 records as we seen earlier, and then over those 2 records again we're going to call the aggregate function and calculate the average rating over those 2 records. So let's rerun the script, and you can see now the average rating for those 2 particular restaurants beginning with the letter C is actually 4 out of 5 stars now. So that's 2 aggregations we've looked at, the count and the average aggregation. I'm going to bring in 2 more now, and that's the minimum and the maximum aggregations. And you can imagine what these do. They calculate the minimum value in a particular column or the maximum value. So let's clear this print statement here, and this time what we're going to look at is the sale database table. So sale.objects.aggregate, what we're going to pass in here is the minimum, so we're going to get the minimum value over the income field in that table. So let's go back to models.py. This sale model represents a table where we track the sales made by restaurants in our system, and each sale has an income, which is in a decimal field, and that tracks the amount of money made in a particular sale in this imaginary system. So let's go back to the script, and what we're doing here is we're aggregating and we're getting the minimum value of the income here. Now you'll notice I've put minimum, but we've actually used the maximum aggregation function, so let's change that to minimum, and what we're going to do is print out the results here. So let's execute the script at the bottom, and you can see the minimum sale made in this particular table is 5.71, and if we go back and change this to maximum, we can change the name of the keyword argument, and we also need to change the name of the aggregation function. If we rerun the script at the bottom, you can see that the maximum sale is 98.89. Now what I'm going to do is quickly go to the management script used to actually create this data. And this is the for loop that creates all 100 sales in the database. And you can see the income field is chosen uniformly at random between 5 and 100. So it makes sense that we have values here such as 5.71 for the minimum value and 98.89 for the maximum value. These are kind of occurring at the boundaries of that range, so it makes sense here that the max and min functions are returning those values. Now the aggregate function can take multiple keyword arguments here if we want to perform multiple aggregations over a database table. So I'm going to bring this to a new line and add back that minimum aggregation that we had earlier. So we're calling the aggregate function, we're passing a minimum and a maximum keyword argument to that, and we're using the associated aggregation functions here over that income field. Let's execute the script, and you can see below we get back a dictionary containing 2 values now for each particular aggregation. And again, we can use additional aggregations as keyword arguments, for example the average. And I'm going to bring in one more aggregation at the moment, that's the sum function. If we wanted to get a total sum of all of the incomes, we can pass another keyword argument, let's call it sum, and we're going to use that sum aggregation function again over the income field in that model, the sale model. So let's execute this script, and if you look at the dictionary that's returned from the aggregate function, you can see we now have 4 keys, and the sum of all incomes is 5,290.99. So we're now calculating the sum of incomes. We have the average income, which is 52, and we have the minimum and maximum aggregations too. So we're calling this aggregate function, we're passing multiple aggregations in, and we're getting a dictionary back with a value for each one of them. So these are very common aggregation functions. Let's see something a little bit different now, it's something very common. Instead of aggregating over the whole table, let's say that we wanted to aggregate a filtered subset of these values. So we might be running some kind of report, and we only want to get the values for the last month of data, or the last 31 days of data. What I'm going to do at the top of the run function is set up a variable called 1 month ago, and we're going to import Django's time zone module at the top. So from Django.utils, let's import the time zone module. So we're setting this variable of 1 month ago, which is equal to timezone.now, and we're subtracting a time delta of 31 days. So it's not exactly 1 month ago, it's an approximation that we're going to use in this video. And then what we're going to do is we're going to get all of the sales that were made in the past month. So we can use the sale.objects.filter function. And if we look at the sale model in models.py, there's a field called datetime. So let's copy that, and we're going to use that in our filter function. And we're only going to get sales whose datetime is greater than or equal to the date specified in this variable 1 month ago. So this statement here is going to get back all sales that were made in the past month. And then what we can do is, rather than calling sale.objects.aggregate, we can use the sales query set that we're getting back on line 12, and we can call the aggregate function on that query set. And that's going to calculate these aggregations only on the sales that were made in the past month. So let's run the script again, and we're going to see the values that are returned from these aggregations. And you can see the minimum value of 6.91 in the past month. We have a maximum value of 99.7. Now you might notice that that's higher than the maximum value before we did the filtering, and that is because I just regenerated this data randomly because the sales that I had were not from the previous month. I originally generated this data quite a while ago when I started this series, so the date time field on these sale models was quite a while past, and therefore I wasn't getting any results when I did this filter statement. So I regenerated the data. That's why we now have a random value that's higher than what we had before, but this is the maximum value as filtered from the past month sales. And we also have the same for the average, it's 58, and the sum is now 3,491. So this is how we can take a date-based aggregation of our database data using Django. And these types of filtered aggregations can be built up very easily with the Django ORM. And for the statisticians among us, there are other aggregation functions that we can use here. For example, we have a standard deviation and a variance aggregation function that we can perform in exactly the same manner as we did here below. So lots of possibilities with Django and aggregation. The key point here is that aggregation will look at the fields that you give it, and it will return a single value based on whatever the aggregation function is. It could be the minimum, the maximum, the sum, the average, the count, and so on. and the aggregate function will return a Python dictionary with each result in that dictionary as a key value pair. Let's now move on to annotation in Django's ORM. Now the difference between aggregation and annotation is that when you annotate values, you're going to get a value added to each model in the query set that you have coming back from the annotate function. Whereas the aggregate function, it does not do that. It returns a single value based on the aggregation. So when you use the annotate function that we're about to see, rather than breaking all of the rows down to a single value, the annotation is going to be applied to all of the models in the query set. So annotation can add new and important data to your Django models in a query set. So let's start with a contrived example here. I'm going to remove this code and I'm going to add a comment here explaining what we want to do here. So let's move connection.queries down to the bottom. What we're going to do is we're going to fetch all restaurants, and then let's assume that we want to get the number of characters in the name of the restaurant. So if our restaurant was called XYZ, we want to add the number 3 to the model. Now what we're going to do at the top here is import another function. We already imported the upper function earlier on, and that transformed the restaurant name to uppercase. We're going to import another function that we can use at the database level, and that's the length function. And we're going to use this to calculate the length of the restaurant name, and then we're going to annotate each model in the query set with that particular number with the length of the name. So let's see how to do that now. We're going to set up a variable here called restaurants, and it's going to be equal to restaurant.objects, and this time we're going to use the .annotate function. Now the annotate function does work similarly to the aggregate function. We can pass a keyword argument representing the name of the field that we're going to annotate on our model. So let's call this one length name. And we're going to set that equal to an expression here where we use that length function that we imported, and we're going to calculate the length of the name field on the restaurant model. So if we go to the restaurant model, this is one of the fields on the model, it's a car field. So we're going to calculate the length of the car field for each row in the database table, and then we're going to annotate that model with this field called len name that contains the number representing the length of the restaurant's name. So in the line below that, let's print something to the terminal. We're going to call restaurants.first to get the first value from that query set, and then we're going to look at the len name attribute which will exist on that object. So let's run the script, and at the bottom you can see that we get back a value of 13. So what's happened here is that the restaurant model, which normally doesn't have a field called len name, has been annotated with that extra information, and that extra information represents the length of a particular field that already exists on the model. And what we can also do here is use the .values function. So what I'm going to do is call .values, and we can get two values here. We're going to get the name, but we can also get the annotated value as well called length name. And we're going to see what output we get back for that particular query. You can see if we look at the terminal, I'm going to expand this. The query set that's returned contains two keys. One has the name of the restaurant, and the other has the annotated field called len name with the length of that restaurant's name. And you can inspect these names and the lengths of the names to verify that this query has worked successfully. So the point of the annotate function is to add additional information to your Django models in a query set based on some kind of aggregation or some kind of database function that's applied to the data in that table. And we can also use these annotations in a filter statement in Django. So let's imagine now that we want to filter these restaurants to only those whose name contains more than 10 characters. So after we've annotated the query set with this function, what we can do is then we can call the .filter function here. So I'm going to call .filter, and then on a new line we're going to specify the filter expression. We're going to take that new field len name that we've annotated on the models, and then we're going to use the greater than operator here. And in fact, let's use the greater than and equal to lookup here, and we pass the value that we want here. In this case it's 10. If we now re-execute this script and we look at the output, you can see that we only get back values whose restaurant's name contains 10 or more characters. And if we change the lookup to just greater than and re-execute this, we're going to see that we get back even less rows in this particular query set. Only 2 are returned whose name contains more than 13 characters. Let's see another annotation here. We're going to use another database function that I'm going to bring in from the functions module, and that function is called concat, and that's used to concatenate 2 or more fields from the database. Let's now see how to use that in this run function below. And in order to use concat, we're also going to bring in a couple of extra fields from the models module. So let me remove all of these aggregations for now, and I'm going to bring in the car field that we've seen on Django models already, and also a value object. We're going to see how to use that in a second. Let's now go down to the run function, and I'm going to remove this code here, and we're going to start by using a concat operator now. And we can also remove this comment. I'm going to add another comment here explaining what we want to do with the concatenation. What we want to return here is something that looks like this. We want to get each restaurant's name here, and then in brackets what we want to get here is the average rating for that restaurant from all of the ratings in the rating table that are applied to that restaurant. So we're going to build this concatenation with the concat function that we've just imported, and what we're going to do is we pass multiple expressions into this function, and the database is going to concatenate these together at the database level and return them to the client. So let's start by adding the restaurant's name here. This is this part of the string that we want to get back from the concat function, the restaurant name, and then what we want after that is we want to add a raw value, and that's why we imported this value object from the models module. We can pass a literal into the value function, and if we look at what we want to construct above, after the restaurant name we want to have a space here and then a bracket with the text called rating. So what I'm going to do is pass that literal in here. We use a space and then bracket, and then the word rating will be put in there along with colon and then another space, and we also want to get rid of the closing bracket because that's going to be applied after we aggregate together the ratings here. So that's our first literal here. After we do that we want to pass in the number, and this number represents the average rating for the restaurant. So what we can do in the concat function is use the average aggregation function, and what we're going to do is import that at the top again from the models module. I think I removed that by accident. We're re-importing that, and what we're passing in is the average, and we're looking at the restaurant table here. So what we're going to do is we're going to get the ratings, and we're going to follow that foreign key to all of the ratings and calculate the rating average here. So just to explain this, the restaurant model has a reverse foreign key to all of its ratings, and we can follow the foreign key to those models and look at the raw rating under the hood, and then we're going to aggregate them with the average function, and then all we need after that is this closing bracket. Once we've calculated the number, we just need to close off this expression, so we can use the value function again, and this time all we're passing in there is that closing bracket. So what I'm going to do is move this expression to a new line. We need one keyword argument to pass in here, and that is the output field. We're going to set the output field to a car field in Django, and what this is going to do is it's going to take these values here, it's going to calculate this concatenation, and then we're telling Django give us back that output as a car field, as a string. So I hope that makes sense. Let's now see how to use this concatenation that we built up as an argument to the annotate function. So I'm going to create a variable here called restaurants again, and the query is going to be restaurant.objects.annotate, and let's pass a variable, a keyword argument here called message, and that's going to be equal to that concatenation that we built up above. So for every restaurant in the table, we're going to calculate this concatenation and add it to each model with a field name of message. So let's now iterate over each restaurant R in that set of restaurants, and what we're going to do is we're going to print out r.message to see what's been added to the model. So let's clear the terminal and rerun this script, and you can see what we get back below is the results of these concatenations. We have the restaurant name, and then we have brackets containing the average rating for each restaurant. So this is a bit of a more complex example. We're taking the concatenation operator and we're passing multiple values to that. For example, the name of a field in the Django model, a raw string value with the value function, and we're also passing another aggregation into the concat operator using, in this case, the average aggregation over the ratings. And then when we've built this concatenation up, we can use it as an argument or a keyword argument here to the annotate function in order to give the Django models that are returned from the database query that extra information that can then be used in your application. For example, you could take the message field that's been added here and you can display that in your Django templates so that end users can see the average ratings for these restaurants. That's just one example, but we're going to move on to some more practical examples now. Let's assume that we want to annotate each restaurant object with its total value of sales. So the total sum of all sales made for that restaurant. I'm going to remove all of this code here, and we're going to start from the top of this function. Let's create another variable called restaurants, and it's going to be equal to restaurant.objects.annotate. And the annotation here we're going to pass in is called total sales. We'll give it that name, and we're going to use the sum aggregation function here, which we need to import again from the models module. And this time from the restaurant, we're going to follow the foreign key to its associated sales, and then we're going to look at the income field on the sale model, and we're going to aggregate those and sum them up for all restaurants in the database. Now what I'm going to do below that is use a print statement, and we're going to pass a list comprehension in here, and for each restaurant in the data we're going to print the total sales. So let's make the terminal a bit bigger and execute this script, and we can see the output here. For each restaurant we're getting back a decimal containing the total sales for that restaurant, and that's been brought in from the sales table. It's been aggregated in the database and summed up for all of the values for that restaurant. Now when we call annotate in this way, we're getting back every single column from the database table as well as any annotated columns as well. So what I'm going to do is bring back the connection.queries so that we can see this, and I'm going to use the pprint function here in order to see this better, and I'm going to remove the print of the total sales. So let's go back to the script and execute that, and we can see the queries that are being executed. I've got no queries here, and that's because I'm not evaluating the query set. So let's bring that back and re-execute. Now if you look below, you can see the SQL query that's being executed. We're getting all of the columns from the restaurant table, and you can notice this column as well where we're using the 𝗬 aggregation function, and we're casting the result of that as a numeric value and returning that with the alias of total sales. And you might also notice there's a group by statement here in the SQL, and we're grouping by every single field on the restaurant table. Now that's fine, but let's say we don't need to get back every single column from the table. After we've performed our annotation, we can then use the .values function to specify the values that we want to get back. So for example, we might want to get the name, but also our aggregated field called total sales, and that is coming from this annotate function, the keyword argument that we pass in there called total sales. Now if we execute the script, we're going to see that we get an error, and that's because we're now returning a dictionary, so we can't use this dot notation. Because this is a dictionary, we need to index in with this syntax here and get that particular key back from the dictionary. So let's rerun this, and now we get back the values accordingly. But if we look at the select statement, you can see we're only getting the name and the aggregated field called total sales. We're no longer looking at every single column. So again, we can use .values in order to limit what's coming back from the database, and that can help improve performance. And remember, what you get back from values are Python dictionaries. So we've seen here how to use annotations to get back summary information that can be added to all models in a query set. For example, here we've annotated each restaurant with the total number of sales that they've made by using the 𝗬 function and following the foreign key to the sale table's income field. Let's comment out connection.queries and remove this code above. Let's see another example now. We want to annotate restaurants with the number of ratings that they've received. We're going to set up a variable here called restaurants, and this time we're going to use restaurant.objects.annotate again. And we can annotate each restaurant with the number of ratings that they've received by giving it a keyword argument, which we'll call num_ratings. And then we're going to use the count aggregation that we saw earlier to count the number of ratings that have been applied to that restaurant model. So let's import count again at the top from the models module, and then below that we're going to use those restaurants that we got back above, and let's call the values function, and we're going to get back the name of the restaurant, and we can also use that annotated field num_ratings, and we're going to see the number of ratings applied to every restaurant in the data. Let's run the script, and you can see that, for example, the first restaurant with the name of 𝗵𝗪 1 has 4 ratings, the second one has 2, and so on. So the numbers here, they're coming from this count aggregation function that we are adding to the annotate method. And again, if we look at the queries quickly, we're going to build up towards something new here. If we look at the SQL that's executed, again we can see the group by operator here, and we're grouping by every single column in the restaurant table. And this is what ensures there's an aggregation for each row in the database. So there's 14 rows in the restaurant table, and for each model that comes back here, we're going to get back an aggregation for the number of ratings for every single row in that table. Now we might want to also get the average rating for those restaurants, and we can do the same with the annotate function as we did before with the aggregate function. We can pass multiple keyword arguments in here, so I'm going to pass a second one in, and this is going to have a keyword argument called average rating, and we're going to calculate the average of the restaurant's ratings using this statement here. If we look at the values function below, as well as the number of ratings and the name, I'm going to add another field here for the average rating. So let's run this script again and remove connection.queries, and we're going to see the output of this, and we can see now as well as the number of ratings, we're getting back an average rating for that restaurant. So again, annotation is being applied for every row in the table that's coming back from this query. So we're gathering the number of ratings and the average rating for every restaurant in the database. Now, we might not want to perform an aggregation for every single row in the database. Instead, you might want to create a specific aggregation by grouping by a subset of the columns. Now, an example of this would be, rather than calculating the average rating for every single restaurant individually, we might want to calculate an average for just, for example, the Italian restaurants in the data. And as well as Italian restaurants, we might just want to calculate these aggregations on each restaurant type so that we can report, for example, on how the average rating differs for Italian restaurants against Indian restaurants and so on. So how can we specify a subset of fields for aggregation here when we use the annotate method? What we can do is, before we call annotate, we can call the .values method. So what I'm going to do is go back to the documentation for the values method, and we're going to read this paragraph at the top. This is very important to understand how annotations work in Django. Now, ordinarily, annotations are generated on a per object basis. An annotated query set will return one result for each object in the original query set, and we've already seen that. However, when a values clause is used to constrain the columns that are returned in the result set, the method for evaluating annotations is slightly different. Instead of returning an annotated result for each result in the original query set, the original results are grouped according to the unique combination of fields specified in the values clause. So an annotation is then provided for each unique group based on the values that we pass into the .values function. And there's an example just below here where we consider an author query that attempts to find out the average rating of books written by each author. So this query, author.objects.annotate, will calculate for each author in the database the average book rating for that author. But if we look below that, you have a different query here where before we call annotate, we're calling the .values method, and we pass the author's name into that method. So in this example, authors will be grouped by the name. So you get an annotated result for each unique author name. Now the difference here is that if you have two authors who have the same name, their results will be merged into a single result in the output of the query. So this is very important. If we use the values function before annotate, the groupings are performed based on these columns that we pass to values. We're going to see an example of this now in our application. What we're going to do is calculate the number of ratings that have been applied to each type of restaurant in the data. Now the difference here is that there are 14 restaurants, and each of these restaurants has a particular type. If we look at the type choices here, they can be an Indian restaurant, Chinese, and so on. So if we use the .values function and we pass in the restaurant type field before we use the annotate function, what's going to happen is the annotations are going to be applied at the level of the restaurant type. So for example, we'll get the number of ratings for each of these types, and that will be returned as values on these models. Let's see an example now. We're going to go back to this script here, and I'm going to remove the average function here for now, and we can remove that from the results below here. So before we call .annotate, what we're going to do is we're going to call .values, and we're going to pass in the field that we want to group by. And in this case, it's the restaurant type field on the restaurant model. We're going to group by that field, and then we're going to calculate the number of ratings that are applied to each of these groups. Now before we run this script and see the output, we're going to remove the .values function here, and we're just going to print the output of this statement here where we use .values and then .annotate. If we run the script below, we can see the output that we get, and this time we have a single field in the returned dictionaries from the .values function. The restaurant type is the key, and that maps to the type of restaurant, for example a Chinese restaurant, and then we get back the number of ratings, the total number applied to all Chinese restaurants in the data. So this time we're getting back a result only for each distinct grouping of that restaurant type field that we're passing into the .values function. So there's only a small subset of restaurant types, for example Chinese, fast food, Indian, Italian, and Mexican. So what we're getting back here is not a result for each row in the table, but we're getting back a result for each distinct grouping. So this allows us to perform more complex aggregations using Django. And if we look at the generated SQL by uncommenting the connection.queries and re-execute the script, let's make the terminal bigger so we can see this. If we look at the group by statement here, you can see that we're grouping only by the restaurant type now. So before we were grouping by every single column in the table in order to get an output for each row, but this time we're grouping by the restaurant type, so we're going to get an output for each distinct restaurant type in the underlying database. So that is the effect of using the .values function and passing a field or set of fields to that before we call the annotate function. When we call values before .annotate, Django is going to use the grouping described by the .values function in order to compute that annotation. So I hope that makes sense. Let's move on to the final thing in this video. We're going to see how we can use the filter and order by functions on these annotated fields that are added to Django models. So let's go back to sales made by restaurants. I'm going to delete this and replace it with this statement here, where we're annotating the restaurants with a total sales field. Let's uncomment connection.queries and we're going to run the script again, and we can see the output here containing all of the restaurants, and each one of these restaurants now has a field called total sales. And we can use a for loop to print out the total sales for each of the restaurants in that query set. So let's execute the script again, and we're going to get back some numbers here. But you can see the numbers are not ordered in any way. They are only ordered by the restaurant primary keys that are coming back naturally from that table. Now the Django ORM does have an order by function, and we can order by the results of an annotation if we chain the .order by function after the annotation, and we can pass the name of the annotated field, and that is total sales. This needs to match what we pass in here. In this case we're ordering by the total sales, and that should give us back a different ordering of this query set based on the number of sales that the restaurant has taken in. So if we re-execute the script, you can see this time the numbers are in order from smallest to largest based on the number of sales that that restaurant has made. So the very first restaurant in this query set is the one that took in the least amount of money from these sales, and the one at the very end is the one that took in the most amount of money. And just like normal in the order by function, if we use this syntax here, we can get back things in reverse order. So the restaurant with the most amount of sales will be first in the query set, and this will now be in descending order, as you can see here. And as well as ordering, we can also use the .filter function to filter the results of this statement based on some sort of value that we pass into the filter function. So you can see the output of the total number of sales on the terminal below. Let's say we only wanted to get back the restaurants who had taken in less than 300 in sales. We can use that annotated field total sales and then chain the less than lookup to that, and we pass in the number 300 here, and then what's going to happen is we're going to get a filtered query set only containing restaurants whose sales or the total sales is less than 300, and you can see that here the values coming back are only those two restaurants who have taken in less than 300 in sales. And if we uncomment the connection.queries and re-execute the script, we're going to look at the SQL query that's generated here. Let's expand the terminal and we can see that we have a select statement. We perform the aggregation here and cast it as a value of total sales. And you can see we're using a group by operator, and again we're grouping by every single field in the restaurant table because we're getting back an annotation for every single row in the table. But what we have below the group by is this having operator in SQL. And this allows us to do some filtering based on aggregated results. So we're taking the results of the group by operator and we're taking this sum here, and we're only returning the values that match this statement here, the values that are less than 300. Now this has been quite a long video. One last thing to show before we finish is that we can actually aggregate the annotated values. So what I'm going to do is remove the for loop, and we're going to look at the restaurants that we got back from the above query, and that's the restaurants whose total sales was less than 300. What we're going to do now is chain the aggregate function to that, so restaurants.aggregate, and we're going to take the two restaurants that we got back above and we're going to calculate the average sales from those restaurants, and we're going to pass this annotated field called total sales into the average aggregation function here, just like that. And what we can do is we can print these results to the terminal, and what we're going to see below is the average total sales for all of the restaurants in the query set that we got back on line 10. Now let's remove connection.queries. Actually, we don't need to see the query, but what we can see in the terminal is that we get back a dictionary with the average sales key, and the value is 252.7 for the two restaurants that we got back in the above query. So the point of this is that we can perform annotations, we can then perform optional filtering and ordering, and then we can aggregate, if we want, the results of those annotations by passing the annotated field into our aggregation functions to return a single value back from the database. So that's all for this video. We've seen a lot of things in this video: how to use the values and values list functions in Django. We've seen how to use the aggregate and annotate functions, and we've seen how we can use the values and annotate functions together in order to perform a specific grouping operation in the underlying database. In the next video, we're going to look at some more advanced querying operations in Django, but for now, if you've enjoyed this video, please like and subscribe to the channel. It'd be much appreciated, and we'll see you in the next video.